I am here now with Jürgen Schneider, and he is the solution manager responsible for the simulation solution applications for battery. And thank you to have the chance to talk to you about the new capabilities in the area of battery simulation. We hear a lot nowadays about electrochemical modeling and the deep dive into the cell modeling. So my first question to you is, what's new in this very challenging and exciting area?
Yeah, thanks, Oliver. Batteries, I think, are a core component in the EV development, and of course, also here we see a strong need to accelerate the battery development. And in order to also support this virtual development, we see here as a key, so simulation, and especially here physical modeling of batteries we see as important. Therefore, we also put a high focus on electrochemical modeling. So we see here a strong request also from the market, and especially here we put a lot of focus in those topics. In already released versions, we see a lot of those models that help understanding processes inside the cell, especially looking really on the anode side, on the cathode side. And there are, let's say, models like SEI layer growth, like lithium plating, also now with last release, electrolyte evaporation, which are also, let's say, the starting points of thermal runaway processes. So all those things have been added already. But on the other side, also, we see there is still some, let's say, challenge for the users to get started with electrochemical models, simply because the parameterization or the characterization of their specific cell seems not to be easy for them. That's why we also added support in doing this parameterization based on the measurement data, as we call these impedance measurements, for example, read data in and extract the specific parameters so that the user is now also able to do this parameterization of electrochemical models. So we see this as a core feature here in the development.
Okay. When we are talking now and hearing the different chemistries and the new chemistries, it's always coming up with a discussion about this breathing and swelling and changing the dimension. So is there something specific also for this area which is new to cover these effects also in the simulation, and how can this be anyway considered?
Yeah, this is, I think, everyone talks about aging, and of course there are a number of aging effects, as I mentioned before, like lithium plating. But more and more when we look at these new chemistries, swelling is really an issue. And therefore, whenever we talk to customers, they always ask, can we also simulate? And now with the upcoming release, we now also have this, with this new release, we have now this model also implemented. So now we can also simulate from the particle or let's say the source down to the microscopical area up to the cell and the module, the effects, and which is really now important, this interaction between the mechanical stress and the electrical behavior. And just what I would like to show here is we have on the one side the particle, where we have, depending on the lithium concentration, of course, here a certain, let's say, shrinking or growing of the particles, or also the gradients in the particles. So this is a starting point. And of course, then when we come to the cell, to the anode, to the cathode, they also will start growing or shrinking. And that's especially something where we have now closed the loop between the, let's say, mechanical stresses and the impact on porosity, for example, of the cell on the, let's say, anode and cathode material, or also the particle enhanced diffusion as an example. I just have brought a video. So maybe if you're just also looking here on the left side, you can see just we are charging now the battery from 0 to 90% SOC. And on the left lower corner, you just see what happens on the particle level. In the middle section, what happens on anode and cathode side. So in the middle, also you can see here this separator, which stays more or less constant. And we also now see how during a charging process of a cell, the volume changes over this process. So on the right side, on the one side, we see how the cell growth. And since we have also connected a compression bed, we see at the same time also how a compression bed is compressed. And that's now really something where we can start working on in investigating how those chemistries, how those effects influence swelling and breathing of cells.
That's really great to see the deep dive into the cell and looking inside even into the particles. This is really great. When we see that such an real time of a whole charging process takes 50 minutes, what does this mean for the engineer as a simulation time? How long does this take?
Yeah, this is one of the key advantages why we would say simulation can help here also reduce effort in testing, because we all know aging tests, they take just not days or weeks, they just can take even a year or longer. So like in this case, simulating 50 minutes of a charging takes in the simulation about a minute, depending of course on CPU power, and that already shows the potential. So you can run a number of different scenarios, different, let's say, designs, and just see what is the impact driving under different environmental conditions, driving under, let's say, different cooling or strategy conditions. And of course, at the end of the day, you just can make, let's say, you can isolate individual effects and investigate that within a couple of minutes instead of weeks.
That's really great having this chance, and also when I see this to have the capability to accelerate by virtualization also the process a lot and the development time. So of course electrochemical model is very important, but there is not only this deep dive development, there is also the control system. So of course, battery management system is a strong focus. What's new for engineers who are working here on the control functions? Is there something new to support also these engineers in the later step of the development process?
Yeah. So we all know, even though we would like to have these electrochemical models directly in the BMS, that's currently still not something that let's say is realistic. Therefore, we still have these equivalent circuit-based models on board. And as an example now, when I have this electrochemical model, I have parameterized, I have validated this model, I can also start now creating, for example, these HPPC tests virtually. So instead of running for my BMS calibration a couple of weeks to get these pulses for my RC fitting, I can, for example, now also simulate within CruiseM this HPPC test. And then we, of course, also have seen there is a strong need to fully automate the process of generating these RC maps, especially now with high flexibility in creating now various temperature or C rate or SOC intervals. And already we have, with the last release, started to offer the so-called battery tester. So you can nicely create now here your HPPC profile and just run it directly here within a couple of minutes, the complete HPPC test. and then automatically read this data in. So as an example, when you have this HPPC profile, you just cut that in slices. Normally you do that manually. We just have here an automatism that automatically detects all the pulses, all the individual temperatures, reads that in, and is doing this fitting automatically. And with that, of course, it's now much easier and again accelerates the development from, let's say, weeks of testing to maybe a day with support of electrochemical models and automatic deriving these parameters.
So just to make sure that I understood it correctly. So on one hand, it's saving testing time, making testing more efficient by also partly virtualizing this, and on the other hand, improving the quality of the models. Is this the correct understanding?
Correct, yeah. So on the one side, of course, when we're doing the simulation, we also can identify, for example, if a pulse is too long, so the relaxation phase more or less could be reduced. And on the other side, we also can identify, for example, for high C rates, maybe a 10 seconds of relaxation phase might be too short. So therefore, we also can provide, let's say, a more efficient testing profile for the test engineers so that they can also reduce testing time there. And of course, the maps can become more detailed because if I run more temperatures, there is not a lot of, let's say, effort in doing this by simulation.
Yeah, that's really cool. Changing now more in general, are there any other updates of existing model or enhancements in your area which you could tell us?
There's of course a lot of those things are going on, especially batteries are such a high dynamic topic that there are so many things that we are working on. But just as a let's say highlight here, just to mention also LFP cells are quite of high interest. So we also have added this chemistry with this phase change mechanism also now to our electrochemical model. On the other side, of course, also when you're working on designing a battery cell, playing around with parameters like the anode layer, the cathode layer thickness, and so immediately also you would like to see a first feedback on what, for example, is the capacity change. So now we have a dedicated KPI section. Whenever you make some design changes on this battery specific parameters, you immediately get an information about how is that changing the characteristic. And finally, of course, electrochemical model not only on the system level are relevant, but also we see that this are important to have that in full 3D. So now also we added these PADEMO cubes, which allow to discretize, let's say, dedicated cell into segments and dedicated regions, also now in full in 3D.
So I understand many new things which are available, also addressing different people, really from cell area, battery management system. You mentioned now last the 3D analysis, also for the design support and verification. Unfortunately, due to time reasons, we cannot extend this too much. But thank you for this short introduction in the news of this release. Thanks a lot, and we are heading and expecting a deep dive into the new release. Thank you.
Welcome.